Texas is booming. Our cities are growing, and the population is expected to almost double over the next 50 years. The drought of 2011 has made Texans increasingly aware that we need to plan now to ensure plenty of clean, safe drinking water for our future. A growing trend to meet future water needs in Texas and throughout the world is for communities to recycle their existing water supply. For the Dallas-Fort Worth area, West Texas, and many other areas, water recycling is the best option to provide a safe, drought-proof, cost-effective source of future drinking water.
There is no new water. We're using the same water that's been here since the beginning of the earth. We just recycle it through natural processes or man-made treatment.
School children learn that we humans today drink the same water the dinosaurs drank. Natural processes filter and clean the Earth's water. So too can humans.
The Earth has the ability to biological treatment. We can now mimic that inside of an engineered system and make it more compact and actually much faster.
Recycling begins with water that has been through a wastewater treatment plant, so it's clean enough to be released into streams and rivers. Recycled water is given additional treatment, either cleaned enough to put back into a city's water supply lake, or in some cases, purified sufficiently to be ready to drink. Treating water enough to put into a water supply lake involves removing nutrients that might cause the lake to have algae blooms. This can be done in a recycling facility that uses high-tech filters and other processes designed to remove excess nutrients. Another method uses special man-made wetlands, such as the beautiful East Fork wetland at the John Bunker Sands Wetland Center.
The East Fork Wetland Project was designed to naturally filter water. Native aquatic plants that were planted in the wetland by hand take out about 70% of nutrients, basically nitrogen, phosphorus, and ammonia. The other part of the story is the bacteria that's hidden under the water's surface. The bacteria are actually using the waste products as their food as well. And that cleans the water, the plants clean the water, and also the sunlight naturally filters the water as well.
When reclaimed water is purified to safe drinking water standards and put directly back into a city's water supply, it is called direct potable recycling. Direct recycling utilizes two basic technologies: membrane filtration to remove bacteria and viruses, and disinfection to kill any remaining organisms. Membrane filtration, such as ultrafiltration and reverse osmosis, uses thousands of specially designed membranes, often shaped like tiny straws. Water is forced through microscopic pores into these straws, filtering out bacteria, viruses, and other impurities.
Membrane technology can produce an extremely high purity of water.
Disinfection consists of treating the water with ultraviolet light and other methods, such as conventional chemicals, to kill harmful organisms. This combination of high-tech filters and disinfection can produce water so pure that it can be put directly back into a city's water system. The process is carefully monitored so it not only meets water quality standards, it exceeds them.
When I speak to groups of engineers, water operators, state regulatory agencies, EPA, this is their job to inspect water systems. They didn't ask me about the safety of the water. It is very good and very safe. We've had this technology for years. The filtration, ultraviolet light, and reverse osmosis. Those are the same things in the bottled water factories.
In order to ensure safety, water recycling facilities are required to both filter and disinfect the water multiple times to produce water that is cleaner than most of what we drink today. This is referred to as using multiple barriers.
The real key is multiple barriers, so that if there was some type of upset in one barrier, that you have these backup barriers. That's the key to having an exemplary safety record.
Additional technologies are emerging to facilitate water recycling, among them ozone BAF, forward osmosis, and underground storage in aquifers. The benefits of all methods of water recycling are far-reaching. In many cases, water recycling is the lowest cost source of additional water supply. It eliminates the substantial cost of building new reservoirs and limits the distance water must be piped. Recycling also avoids the added water loss due to evaporation from a new reservoir. Recycling has a much smaller environmental impact than building new reservoirs by avoiding the need to flood productive agricultural land or wildlife habitats. Advanced purification facilities using membrane filtration can be added onto existing wastewater treatment plants, offering substantial cost savings and impacting only a few acres. Wetland filtration sites also use less land than building new reservoirs. For example, the East Fork wetland covers 1,800 acres, yet it produces almost the same amount of water as Lake Lavon, which occupies 25,000 acres.
Another important part about this wetland, we're basically designed something that is not only helping us, but you hear the wildlife around us. It's amazing. We have 254 different bird species that we've seen. We have river otter that walk on the boardwalk that we're on, bobcats that rest on the rail, multitude of amphibians. We're helping nature to help man.
Water recycling gives cities the ability to efficiently reuse the water they already own. Numerous studies predict drier times ahead and an increased probability of droughts lasting a decade or more. Water recycling is drought-proof. It takes the water that is already developed by our communities and purifies it so that it can be safely reused again and again. When the time comes for your city to decide on a new water supply option, consider the benefits of water recycling. Then choose a source that is safe, cost-effective, and drought-proof. Water recycling.